My name's Dan Harris, Vice President of Engineering at Ddanko. This training video today will give you an overview of how to undertake a simple active chill beam selection for a typical office. The first step with utilising the Ddanko Excel-based selection program is to enter our overall design conditions for the space. We enter those in this location here. The first step is to enter the heating and cooling room design conditions, then our air handling design delivered conditions to each of the ACBs, and then we have our entering water for both chill water and heating water. On the left hand side, we then enter the zone information and the zone requirements. In this case, we've got one office located in the northwest corner of the building on the perimeter. It's 300 square feet, and in this example, we have about 40 BTUs per square foot of sensible cooling capacity for a total of 12,000 BTUs, and a latent load of 3 BTUs per square foot for 900 BTUs of latent load. The heating load is 20 BTUs per square foot, resulting in 6,000 BTUs of heating capacity. The minimum outside air requirement to meet the code requirement for this office was 60 CFM. The next step is to undertake and determine roughly how many active chilled beams we want to install into this location. So given that this is a 300 square foot perimeter office, a good rule of thumb is to use one perimeter chill beam every 100 to 150 square feet. If I was to try and deliver this capacity with one chilled beam, as you can see, I would need 12,000 BTUs per beam, which is too high per beam. So we can change the number of beams from 1 to 2, and the remaining useful information area of the program updates with the new requirements per beam. The software is written so that the default primary airflow rate that is put into the selection meets either the minimum primary air required for that zone or the minimum primary air required to meet the latent capacity for that zone. This column indicates that we're still short on delivered cooling capacity compared to what the load is requiring. So we need to now update either the length, pressure, primary airflow rate and water flow rate in order to get additional cooling capacity to the space to meet the zone requirements. So with a typical chill beam selection, once you've set the length of the beam that you would like, the easiest way to deliver additional capacity is to increase the airflow rate. So we can take that up to 80 CFM, and as you can see, we're still 369 BTUs short. If we take that to then 85, still just a little short. So at 90 CFM, for this 4-foot ACB 40, we can deliver the sensible requirements to that space. We may even want to adjust the water flow rate down a little in order to get pretty close to the required sensible cooling capacity. So we've now undertaken a 4-foot ACB 40 selection that meets the sensible requirements, the latent requirements for that zone, and we can see over further to the right hand side of the portion that we now need to have a closer look at the heating capacity. So we can scroll back to the left and see that the heating requirement per beam is 3,000 BTUs, and at 0.5 GPM of water flow rate we're delivering 4,500, so we're good there. The zone summary provides the overall primary air and technical summary for each of the zones, including all of the beams in that zone. So you can see we had 2 beams at 90 CFM for a total primary airflow rate to the zone of 180 CFM. And we also provide additional information for your analysis and reviewing of the quality of the selection for primary airflow rate per square feet and the total zone supply airflow rate per square foot. Noise levels, operating weights, and beam densities are also displayed. That gives you an overview of how to undertake a simple selection using the Ddanko selection software program.